Alright, so we're going to look at section 5.1, which is finding the area in between curves. So we'll start with the formula to find the area in between curves. Alright, so to find the area in between curves, you take the integral from a to b of the absolute value of f of x minus g of x dx. So you're going to subtract your functions, except you'll take the absolute value of that, and you'll take the integral from a to b. So if I look at example 1, I want to find the area bounded by y equals x squared plus 1 and y equals x from 0 to 1. Okay, so that tells me that I'm taking the integral from 0 to 1. My f of x is x squared plus 1, so I'm going to take the absolute value of x squared plus 1 minus my second function is x dx. Okay, so if I simplify that function, I get x squared minus x plus 1 dx. And I'm still integrating that from 0 to 1. If I remember my formula for integration, then this would integrate to 2 plus 1 is 3, so x cubed over 3 minus 1 plus 1 is 2, so x squared over 2. And 1 integrates to 1x, so x from 1 to 0. Just plug them in. So I plug in 1, I get 1 cubed over 3 minus 1 squared over 2 plus 1 minus 0 cubed over 3 minus 0 squared over 2 plus 0. 0 cubed over 3 cancels. 0 squared over 2 is 0, plus 0 is 0. So if I simplify up front, 1 cubed is 1, so 1/3 minus 1 squared is 1, so 1/2 plus 1. And if I make them have common denominators, 1/3 is the same thing as 2/6. 1/2 is the same thing as 3/6. And 1 is the same thing as 6/6. So 2 minus 3 is -1, plus 6 is 5. So 5/6 ends up being what that equals. Okay, so let's do the same thing for example 2. Find the area between y equals x squared and y equals 2x minus x squared. It doesn't give us our upper and lower limits, so we need to find our upper and lower limits first. In order to find that, you have to figure out when these functions are equal to each other. So I'm going to set x squared equal to 2x minus x squared. Okay, that will tell me when if I solve that, that'll tell me when my functions are equal to each other and give me my limits. So if I add x squared and subtract 2x, then I get 2x squared minus 2x equals 0. And if I factor out a 2x, then I get 2x times x minus 1 equals 0. So that tells me that 2x equals 0 and x minus 1 equals 0. And then if I solve that for x, I get x equals 0 and x equals 1. So now I know my upper and lower limits. The second part of that is then taking the integral from 0 to 1 of my original function, which is x squared, minus my secondary function, 2x minus x squared dx. If I distribute my minus sign, then I get x squared minus 2x plus x squared dx. And if I combine my like terms, then I would get 2x squared minus 2x dx. Now that I have that simplified, I can actually integrate it. So 2 plus 1 is 3, so 2x cubed over 3. 1 plus 1 is 2, so 2x squared over 2. Then my 2's cancel, and I'm going to integrate that from 1 to 0. So if I plug in 1, I get 2 times 1 cubed over 3 minus 1 squared, minus 2 times 0 cubed over 3 minus 0 squared. 1 cubed is 1, 1 times 2 is 2, so 2 thirds. 1 squared is 1. 0 cubed times 2 times 0 is 0. 0 squared is 0. So I get 2 thirds minus 1. 1 is the same thing as 3 over 3. So 2 thirds minus 3 thirds gives me negative 1 third. Okay, we'll do one more. We'll find the area in between sine of x, cosine of x from 0 to pi over 2. Alright, so my lower limit is 0, my upper limit is pi over 2. My first function is sine of x minus cosine of x dx. What is the integral of sine of x? Cosine. Okay, so sine integrates to cosine of x. What is then cosine of x? Negative sine, I believe, of x from pi over 2 to 0. So then if I simplify, I get cosine of x plus sine of x from pi over 2 to 0. So by plugging in pi over 2, I get cosine of pi over 2 plus sine of pi over 2 minus cosine of 0 plus sine of 0. Okay, well, what's cosine of pi over 2? Okay, so cosine of pi over 2 is 0. What's sine of pi over 2? 1. Okay. Minus what's cosine of 0? 1. And sine of 0 is, so 0 plus 1 minus 1 minus 0 is 0. That's it. So you have your work to page 349, 1 through 4, 13 through 16, and 31 through 32.